Okay, today we are going to start our part of the unit on graphing trig functions. Now we're just going to be graphing sine and cosine with a couple of changes. Now, in order to be able to help you do this a little bit easier, because some of this can be done with the calculator, but there's some ways to make it a lot easier where there's not as much opportunity to screw some things up. You've been given this trig graphs help sheet, okay, where we talk about some of the pieces of a trig function. And we're going to take a look today at these two things. This value a that can be in front of my sine or cosine value, okay, called the amplitude, which will make a graph stretch up or down, and something called a period, this b value, that's going to make things stretch left or right. So to help with this, I've given you a little chart that does in both degrees and radians what your sine and your cosine values are. You're like, no, where do these come from? You just like make this up, or how does this work? So I wanted to take just a minute to show you how this works before we actually start doing it. So if we pull up our calculator, okay, since our first part here, I noticed from my graph we're in degrees, I can go ahead and keep my calculator in degrees. So make sure, again, we talked about how the class is growing between radians and degrees. So make sure for now you're in degrees, because that's what your graph looks like. And go ahead and type in just sine of x, because I can't use theta in my calculator. So I'll type in sine of x. And when I do that and I hit graph, I don't see a whole lot going on here. Now there's a reason for this. So I'll show you in a second why this kind of looks flat like this. So what I'm going to do though is I'm going to hit second graph. I'm going to look at my table right now. And if you look, my degree measures, you're like, wait, mine are 0, 1, 2, 3, 4. You know, why are yours all like this? I'm going by the degrees that I see on here. You're like, well, how do I get mine to do this? Okay, here's how this works. If you hit second and window, that's where your table setup is. And normally when your calculator's going, it looks like this. But for our purposes, since we wanted to count by our degree measures, we're going to count by 90 instead. So I get there. Let me go back to my chart now. So for these, again, when we're graphing in degrees, it's second, window, so that's what we did here. And then I want my table set to be 90 if I'm working with degrees. Okay, so back to our chart, and you'll notice it goes along the same we do here. 0, 1, 0, negative 1, 0. And the pattern just keeps going and going and going forever and ever and ever and ever and ever. Okay? So that's where that one comes from. And you'll never guess if I change it to cosine of x and go, there's where my 1, 0, negative 1, 0, 1 comes from. So these are my bases of any sine or cosine graph. Now, are they always just going to stay sine and cosine though? Well, not exactly. So what we're going to do is we're going to take a peek at how some of these things can change what's going on with my graph. So normally, and what I'm going to do with you is we're going to kind of sketch our normal graph first, because you'll always have your chart. So since this is a sine, let me put this back up. With sine, we start at 0. At 90, we go up to 1. And then back down to negative 1. And you notice how the pattern, 0, 1, 0, negative 1, 0, 1, 0. So I can fill up my whole graph. Don't connect the dots yet though. Or if you want to, let's just do it with a dotted line for right now. Okay, that's my base graph. The color that you picked up now, I want you to take, and here's how we're going to get the actual graph of this. We've taken care of this part. We haven't taken care of this guy yet. Well, what's he do? That's called an amplitude. My A value changes. You multiply by the sine or cosine value to find that new stretch. So in other words, at 0, what's 0 times 4 equal? Well, Harty, it's still 0. Okay. So let's put a big dot there. When I get to 90, what's 1 times 4? Well, it's 4. Okay. So it stretches up to here. At 180, 0 times 4, 0. At 270, negative 1 times 4 is negative 4. And at 360, we're back to 0. And again, these are curves. Now, if I wanted to keep the pattern going, let's see. 0, 4, 0, negative 4, 0, 4, 0. And the purple one is my actual graph. Now, some of you may get to a point that you don't need to sketch this other one to kind of see what's going on. Maybe you'll just make a chart and do it. And we're actually going to do that on the next one, because I always like to give you options to see how these go. But that turns out a pretty neat way. We're going to go past number 2 for just a second. I want to come down to number 3. Now, you're like, same thing, except it's 2, right? So here's what some of you may choose to do sometime. You're like, okay, my degree measures are 0 and 90 and 180 and 270 and 360. Okay. My values, or we could call it my sine value, normally, again, is 0, 1, 0, negative 1, 0. But I notice I'm going to times those by 2. So I pull my little chart back up and I go, okay, so let's see. 2 times 0 is 0. 2 times 1 is 2. 2 times 0 is 0. 2 times negative 1 is negative 2. 2 times 0 is 0. And then I wouldn't have to do both. I would just plot the points that I have here. And then I would just keep going with the pattern myself. But you'll notice this isn't as curvaceous as number 1 is, because my amplitude, my A value, is a little bit smaller. So that's just something to kind of keep track of. Now, other things can change though. And those are some things that I have to be cautious of. So for instance, let's say we look at number 2. Now, I notice it's cosine now instead of sine. I notice there's a number in front, okay. But here's what changes this time. My B value is 2. What's that mean? What that means is normally my period, my values that I look for to plot are 0 through 360, because it completes a cycle. Notice I started at 0, I ended at 0, okay? You start and end in the same place. That's the completion of a cycle or a period. Well, when I get here with my B value, when my B changes, which it did, divide 360 by that value. Okay, so 360 divided by 2, oops, let's bring down a little here, is 180 degrees. Which is my new period. Well, what does that mean? That means if I go to make a chart, instead of my chart going from 0 to 360 at the end, it's going to start at 0, and it's going to end at 180. Well, how do I get the numbers in the middle? Well, let's think about it for a second. Basically, what I do is I divide my degree measures by 2. So in other words, 90 divided by 2, 45. 180 divided by 2, 90. 270 divided by 2, 135. And I get my new angle measures that way. So that's what this value in front of theta is, this B value. It just changes my degree measures. But now, I'm going to take my cosine value and times it by 3, because that's what my A equals, my amplitude. So I go for a minute, I go, okay, there's my cosine values. So 1 times 3 is 3. 0, negative 3, 0, 3. I don't have to get cute with this. So 0, 3. At 45, you're like, wait a minute, Harty. Where's 45? I don't see 45. Why don't you have 45? Okay. Again, if you really want to, because most of the time I'm going to leave you blanks on these instead of having them be this way. But if you need to, one thing that we can do is we can go ahead, if you would rather, and I have a feeling some of you would rather. If once you get your degree measures and you want to make a change on this, I do not have an issue with you changing these and just having them go up by 45. Okay? So then at 45, we'd be back to 0. At 90, negative 3. 135 is at 0. 180 is back to 3, and just keep going with the pattern. But again, curve, not straight lines like this is an absolute value equation or something like that. But again, my period is between those two places because I start up at 3, I go down, I come back up, oops, I'm back up to 3, and that's where I start. That's what's called a cycle or a period. So you're like, okay, I don't know about this, Harty. Okay, let's make some more comparisons here. Here's one I like to do. We're going to look at 3. You're like, 3 and 4 are almost the same. Not quite the same, though. And we're going to rewrite number 4. If you ever get one where you have theta divided by something, really all that means it's like 1/2 in this case theta. So you're like, okay, so it's all of these values because it's times 2 again, but my degrees are going to change. You're right. My b value is 1/2. So now I have to do 360 divided by 1/2. Now be careful, 360 divided by 1/2 isn't 180. We just looked up above, 360 divided by 2 is 180. When you divide by a fraction, that actually makes this smaller. So let's get out of here for a second. 360 divided by, and I'm just going to use 0.5, is 720. So 720 is going to be my new period. So we start with 0. We end with 720. And again, just like we did before, I'm going to take each of these. 360 to 720. Looks like times 2. So let's think about this for a second. Okay. When you divide by 1/2, that's the same as multiply by 2. Because if you divide by something, you multiply by its reciprocal. So I take each of my angles and I multiply them by 2. 180, 360, 540, and 720. Good, I know I did it right because it ended up in the right place. And this time we've actually got them labeled the right way. And then my sine values times 2. Well, I just did that in this one, so I'm going to copy those. So you start to look to see what the difference is. You're like, well, Harty, those graphs look the same. Now remember, though, we counted in different quantities, though. Like here to that second line was 90, here was to 180. So if we had them in equal sizes, this one would stretch out further. But for simplicity, for our sakes, we kept the labels going that way to change things up a little bit. But again, it just comes back to knowing those two things. If there's a number in front of my theta, we divide by 360. That tells me my new period. If there's a number in front, we just multiply our values from our chart with those to make life a little bit simpler. Now, notice we've done everything in degrees so far. We're going to tweak that a little bit because we've talked before about the trig language of love is radians. So, we don't want to just speak our own language, degrees, we also want to speak Trig's language. So, to the back we go, and we start talking in trig. Now, all the ideas are still the same. The difference now, though, is going to be how we go about this. Because now, when I'm doing my degree measures, I'm not going to use 0, 90, 180, 270, and 360. Now I'm going to use radians. So pi over 2, because again, pi is 180. 180 divided by 2 is 90. That's where it comes from. Pi is 180. 3 pi over 2. And 2 pi. That's going to be my base angle. And then I'm going to have my sine value times 3. So I start working down my sine chart, multiplying each of those numbers by 3. Now, before we just dot this and go on, some of you I know would like to be able to check this in your calculator. Now, this changes a little bit again, because remember, we are now in radians instead. So, for me to be able to type this in, I need to change a couple things. First, my mode would need to be in radians. So if I go to a calculator, I gotta check two things. I need to make sure my mode is in radians. Then I need to also do my table set. So second window, now instead of going by 90s, I want to go by its radian equivalent, pi over 2. So for my table set, I'm going to use second and up arrow, or whatever your pi button is on your calculator, divided by 2. Now here's going to be the kicker though. Watch when I go to my chart. So second window, and then my table set's going to be pi over 2. You're like, oh, what's up with all the decimals, Harty? I mean, I know 3.14, that's pi. 1.57 is half a pi. 4.71 is 3 pi over 2. See, this is why I don't want to play with the calculator a whole lot. 6.28 is 2 pi. So I want you to see, when I graph it, I actually get to see that funky curve that we were doing before, because when we go into radians, we get to see that easier. So now, but notice, again, when I'm looking at my chart, 0, 3, 0, negative 3, 0, and it goes on and on. So you see that this actually does work. So 0, 3, 0, negative 3, 0, and just keep following the pattern. Back up, back down, curvy, 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 and we're set. So all the rules from before are going to apply here. They're going to keep working the same way. So I want to look at a couple more just to make sure we've got this. I'm going to come down here to 9. We're going to take a look at 9 and 10. So you're like, okay, my A value is 4. So I'm going to take my sine value, whatever it is, I'm going to do times 4. We got to wait on that though. So I'm like, okay. Now I'm going to look for my theta values. Now I remember from before, okay, so this is really 4 times sine of 1/2 theta. So my B is a half. But now we're speaking in radian. So instead of doing 360 divided by a half, I'm going to do 2 pi divided by a half. Now don't let that freak you out. Let's think about this for a second. 2 pi divided by 1/2. When we're dealing with fractions, we know when we're dividing, we flip the second fraction. Okay, so my period now is going to be 4 pi. In other words, and no, it's not time to go yet. So my new period is 4 pi. Or in other words, I need to multiply my angles by 2. Because remember, we said when we divided by a half, it was the same as multiplying by 2. So I'm like, okay, bring this back down. If I need to do some scratch work on this, that's not a bad thing. Okay, you multiply 0 by 2, that doesn't change much. I know at the end, my answer there is going to be 4 pi. But then I start looking at the rest, and I'm like, okay, so my next one's pi over 2. So pi over 2 times 2, oh, those just cancel. That's pi. Okay. Pi times 2, well, that's 2 pi. Do I even have to do the math for that next one? 0 pi, 1 pi, 2 pi, pi, 4 pi. Oh, it's 3 pi. Now, if you want to check, we can. 3 pi over 2 times 2 over 1. Oh, yeah, it's worth 3 pi. Okay. So I do have to make that adjustment when I'm doing this. And then I just take my sign values. So 0 times 4 is 0. 1 times 4 is 4. 0. Negative 4. 0. But use your chart. Have it there as an aid, as an assistance to help you as you start getting used to this. And I'm set. So for any of these, that's all that I'm really on the lookout for. So I start to look, I'm like, okay, I might be getting the hang of this a little bit. So I look here, I'm like, okay, my A is 4, there's a 4 in front here. So when I go to chart this, I know it's going to be my cosine value times 4, so I know that'll be my chart to the right. Here, my B value is 2. So my period is 2 pi divided by 2, or pi. So I'm like, okay, so it's pi at the end, it's 0 at the start. So now how do I get those other ones again? Okay, so here we're dividing by 2. So we divide each angle by 2. Or, when you divide by 2, let's see here, divide by 2 or multiply by the reciprocal. That's what I like to do. You're like, now why are you going to multiply by a half? Why is that easier than just dividing? Well, check this out. Okay, so I start to think about this. And I'm like, okay, I got my handy dandy chart here. So the next one's pi over 2. Pi over 2 times 1/2. See how the multiplying part's always going to be easier if you just multiply by the flip of your B? Multiply by a half. Multiply by 2. I'm just doing the inverse. And I just multiply straight across. Okay, my next one's pi, or pi over 1. Pi over 2. Last one, 3 pi over 2 times a half. 3 pi over 4. And I've got my angles. So whatever that B value is, we're going to multiply our base angles by the inverse, and that's going to get me my new ones. And then I just take my chart and I go, okay, my cosine values times 4, 4, 0, negative 4, 0, 4. And I plot them. 0, 4. You're like, wait, Harty, you got things missing again. Oh, but this time we don't have to cross things out. Here's why. Here's pi over 2. Right in the middle, pi over 4. Again, not time to go. Just Harty using his lunch period. 3 pi over 4 comes before pi. And if I keep going, which I can, notice I'm going every line this time. Down, down, and up, and up. And I get my angle. Okay? Now, I've got one more I've got planned, and if we need to do some of the other ones after that, you're like, wait, how does this work? We can do that. So, okay, one last one. I want to do number 12, because this is kind of weird, but it kind of puts everything together. I'm like, okay, a value is 4. Sine value times 4. Okay. Ooh. Remember, this is 4 sine 1/4 theta. So my b is 1/4. In other words, my period is 2 pi divided by 1/4. But we keep saying divide by 1/4, same as multiply by its inverse. In other words, multiplying by 4. 2 pi times 4 is 8 pi. And that's my new period. So I start at 0. I'm going to end at 8 pi. But again, each of my measurements, each of my degree measures, we're going to be what? Multiplying by 4. So if I need to do a little side work, and there's nothing wrong with that, I can be like, okay, here's my piece of scratch paper so I can keep this neat. So it starts at pi over 2, but I'm going to multiply it by 4. 4 pi over 2. 4 divided by 2 is 2. So then I move to the next one. I'm like, okay, pi times 4. Well, that's 4 pi. Now again, let's look at the pattern. 0, 2, 4. Hopefully somebody said 6 in there. 6, 8. Because I just see it's counting by those 2's. And then I just take, again, my sine values and multiply them by 4. And again, if I want to keep stretching this out, I can. And I'm set. Keep your handy dandy help sheet with you. You will be able to use it as we move along. If you have other issues, that's fine too. But you've got a worksheet that kind of gets over some of the same ones as always. The key's up front, so let me know if I can be of any other assistance.